So about 8 years ago, Brett Victor had this talk out rather, where he said you should have a principle about an internal principle to guide your actions about what you're inventing. His principle was to help creators get closer to their inventions or the medium that they're inventing in. So I just want to show you this clip from this one video, that talk.
1.2. And now we have a working circuit.
Oh, it's on
I mean, I assume it's a working circuit. I don't actually see anything working here. So this is exactly the same as writing code, that we work in this static representation, but what we actually care about is the data, the values of the variables, and we can't see that here. Now, in a circuit, the variables are the voltages on these different wires. So each of these wires has a voltage that's changing over time, and we have to be able to see that. Now, if I was building this circuit on a lab bench, building it physically, I could at least take an oscilloscope and kind of poke around and see what's going on in the different wires, what's going on here or here. So at the very least, I should be able to do that. So what I have here is a plot of the voltage on this wire over time. We can see it's high, it's low, high, and low. So this is clearly oscillating. If I built this physically, also I would actually be able to see the circuit doing something. So in this case, I've got these two LEDs up here. These are LEDs, the little lights. Presumably they're there for a reason. I can hit play and watch it simulate out in real time. So now you can see what the circuit's doing. In order to design a circuit like this, you have to understand the voltage on every wire. You have to understand how all the voltages are changing throughout the entire circuit. And just like coding, either the environment shows that to you or you simulate it in your head. And I have better things to do with my head than simulate what electrons are doing. So what I'm going to do, I'm going to spread these out a little bit. So same circuit, spread out a little bit. And I'm going to add the voltage at every node. So now you can see every voltage throughout the circuit. And I can even hit play and watch it all kind of simulate out in real time. Although what I prefer to do is just move my mouse over it, and I can kind of look in areas that are interesting to me and see what the values are. I can compare any two nodes. So if you look at, say, the node over here, while I mouse over this one, you can see the shadow of the one I'm mousing over is overlaid on that. The shadow of the one I'm mousing over is actually overlaid on all of them. And so I can compare any two nodes just by mousing over one of them and looking at the other one. And again, I can immediately see the results of my changes. So I've got the 70K resistor here. I want to change its value. I just click and drag it. And now I see the waveforms changing immediately. And you'll notice that when I click and drag, it leaves behind the shadow of the waveform before I started dragging. So I can compare. I can immediately see the results of my changes. Two golden rules of information design. Show the data, show comparisons. That's all I'm doing here. But even this isn't quite good enough. What we're seeing here are the voltages, but in electronics there's actually two data types. There's voltage and there's current. And what we're not seeing is the current flowing through each of these components. And in order to design a circuit, you need to understand both the voltage and the current. You need to understand the interplay between the two. That's what analog design is. So what I'm going to do is spread these out a little bit more, and now I'm going to replace each of these components with a plot of the current going through it over time. So each of these blue boxes represents a component, and you can see which component it is because it has a little badge in the corner, a little icon. But now you can see everything that's going on in the circuit. You can see how the current changes. You can see how voltage and the current changes. There's nothing hidden. There's nothing to simulate in your head. So what we have here is a different way of representing a circuit. Just in general, you could draw any circuit with these blocks, but instead of being made out of little squiggly symbols, it's made out of data. And I think it's important to ask, why do we have these squiggly symbols in the first place? Why do they exist? They exist because they're easy to draw with pencil on paper. This is not paper. So when you have a new medium, you have to rethink these things. You have to think, how can this new medium allow us a more immediate connection to what we're making?
Very well said, Brett Victor. This is part of the Nikipedia project where I archive what I'm learning on over video. And I'm also working on another project, which is I'm scraping all the scripts from YouTube clips, and I'm trying to make those transcripts searchable. So they'll be better than the end of those, my captions there at the end. They'll be tidied up. But I'm making like a searchable database for YouTube captions. Thanks for watching and stay snazzy. That's not my end line.